Hi guys, today we're going to be looking at how to perform computations for simple interest and compound interest in Excel. So we're going to try to do our best to solve the questions that were assigned. In this case, we are trying to find simple interest given the principal, the rate, and the time. Okay. First of all, let's go through um, some of the details about Excel. Try to save your file so it has your name and the assignment associated with it. So this is an example. Name your sheets. I've already named my sheets here: 3.1, 3.2, 3.3, 3.4. Let me name this one. To name this one, I'm going to just double click here and then enter 3.5. Okay. So make sure that you name your sheets. Okay. We're going to follow the instructions that were given to you in order to solve the question. First of all, let us populate the cells. So we're going to go to A1 and enter ordinary simple interest. Okay, we then go to A3 and enter principal. Rate and then time, skip and then interest. We can format this more so it looks prettier, but what we're focused on is how to get the values. According to the question, we have to find the ordinary unexact simple interest on a 60-day loan of $1,500 at 14.5%. Right, so let's enter the principal, which is 1,500. I will format the cells right now. The rate, to enter the rate, I need to convert the 14.5% as a decimal. So I will enter 0.145, and then the time, which is 60 days. Okay, now we're gonna enter the formula for the interest. Let's adjust these cells. So this we're gonna make it currency. And here rate as a percentage. Let's increase the decimal place to get the 14.5. Now to enter the formula, remember that we have to start with an equal sign. Okay, so let's start with that. We start by entering an equal sign, equals, then we select the principal, then put an asterisk. The asterisk implies multiplication. Then we select the rate, asterisk again. We can now enter open parenthesis, the 60, and then we divide by the time for ordinary simple interest, which is 360. Okay. We close the parenthesis, so we're entering as is, and that gives us 36 with 25 cents. Notice that in this example, we could have also done the formula slightly different, so please follow. You would have entered open parenthesis, asterisk, asterisk, close parenthesis, and divide by 360, and it would have given us the same result. So here we have to follow our order of operations. Make sure that you know your order of operations well in order to be able to perform the computations. Okay, if we're to do this using exact simple interest, right, it's the same thing that we're going to be doing. So what I'm going to do is copy these cells and just replace the word here exact. The principal, the rate, and the time remain the same. The only thing that is different here is that we're going to change how we compute the actual interest rate. So we divide by 365 here and then hit equals. Similarly here, we just need to change this to 365 and then hit equals. You're going to now get the exact simple interest. Okay, let's move on to the next exercise, 3.2. In this case, we're calculating rate, so we have to look at the formula that we have and the information. So since we're looking for rate, we're going to label this as rate. We need to know the principal. Similarly, the interest in this case, and the time. Okay, that will give us the rate. Okay, so let's enter the principal again. In this case, we are looking at a question that reads as follows: at what rate of simple interest will $1,200 accumulate interest at $72 in 6 months? Okay, so the principal here is 1,200. The interest rate, the interest is $72, so we enter here 72. Here we can adjust this. Oh, it's already in currency. We can adjust this to currency one time since both of them are currency. The time will be 6 months, so we're going to enter 6 here. Now to calculate the rate, we're going to enter equals the interest, which is 72, divided by, notice I'm going to enter open parentheses, the principal asterisk times the time. Now notice here we need to represent time in years, so I'm going to open parentheses again, 6 divided by 12, so that will give us the 6 months in years, close parentheses, and now we can hit equals. That will give us 0.12, but remember that interest rate is given as a percentage, so we change this to a percentage. That gives us 12%. Okay, let's move on to the next exercise. In the next exercise, we're looking for time. So we need the principal, the rate, and the interest. Okay. Let's move the interest to the top. Okay, and that will give us a time. The order really doesn't matter once you have the correct formula, but I'm putting it in such a way that we have the interest divided by principal times rate. Okay, so the interest here in this question, it says how long will it take for $500 to accumulate to at least $560 at 13.14% ordinary simple interest. So in this question, we want to calculate time, so we need to know the interest, which is, since the value accumulates to 560 and the initial investment is 500, so the difference will be $60. Okay, so here we enter 60, changes to currency, and the principal, which will be 500, change to currency, the rate, which is 13.14%, so we change it to a decimal, change it to a percentage one time, increase the decimal, so we can see the 13.25%. Now we can calculate the time, so this will equal to the interest divided by, open parenthesis, the 500 times the rate, close parenthesis. Now notice that in this case we get 0.90566. If we increase the decimal, we're gonna notice that we still don't get something that looks realistic. But what really this represents is 0.90566037736 of a year. So to get the time in days or approximate days, we're gonna multiply this by 365 or 360. Okay, depending on the rate. So let's multiply it by both. Right, so let's get it in days. So equals this times 365, and then equals this times 360. Okay, we can round this to approximately 327 days. Okay, so the answer would be 327 days approximately. Okay, let's move on to the next exercise. In this case, we are looking for the accumulated value. The question reads: a man borrows $1,000 for 220 days at 12.17%. What amount must he repay? So when we calculate this question, right, we are looking for the accumulated value. We need to know the principal or the initial investment. We need to know the rate and the time. So to calculate the accumulated value, the principal is $1,000. The rate is 12.17%, so it's 0.1217, and the time is 220 days. So it changes to currency. This is the rate. The accumulated value will then be equal to the principal times, open parenthesis, 1 plus the rate times the number of days divided by 360. Close parenthesis, and you get 1,074 with 37. Okay. For the 3.5, we're looking for the discounted value or the present value. The question reads: 80 days after borrowing money, a person pays back exactly $850. How much was borrowed if the $850 payment includes principal and simple interest at 9 3/4%? Since the question reads that the 850 includes principal and simple interest, that implies that that is the accumulated value. So in order to get the discounted value, we need to use the discounted value formula as given. So here we are finding the discounted value. So we need to know the accumulated value, the rate, and time. So let's enter that information. The accumulated value will be $850. The rate is 9 3/4%, so that will be 0.0975, and the time is for 80 days. Now we can calculate the discounted value or the present value. Let's format these to currency and to percentage. Let's increase the decimal places. We get a 9.75%. So equals to the 850 asterisk, open parenthesis, 1 plus the rate times the time divided by 360. Remember that in this case, this is discounted value, so we need a power of -1. Enter. We get 831 with 97 cents. Okay. So remember that in these computations, we need to ensure that we have clear information regarding the what we need to calculate and using the correct input for Excel. Okay, let's move on to the last exercise, which is to calculate the compound interest or equivalent rates, commonly known as the annual effective rate. It's a special kind of annual effective rate. Okay, so let's call this EAR. So in order to do this, we're going to fill out the information and enter it. Okay, so here we're going to enter effective annual rate based on frequency of compounding. All right, the nominal rate. Remember that nominal rate simply means the rate annual. So here I'm entering just the information. So what we're going to do is format the cells so that it fits. I'm going to merge all of these cells here into one. So what I did there is selected all the cells so that they fit into the column. We can expand it daily, just a little bit. Center this so that all of them are centered. We can also select them and have the same width in this manner. Okay, so once again, select all of them and just expand it or compress it however you like. Okay, let's bold these just to highlight the cells. We can add borders so it's more clear and identifiable. Let's enter the interest rates. So we need to enter 1%, 5%, 10%, and so forth. So 0.01 for 1%, 0.05, 0.1 for 10%, 0.15 for 15%, 0.2 for 20%, 0.3 for 30%, 0.4 for 40%, and 0.5 for 50%. We then format the cells to percentage and we get the corresponding rates. We can increase the decimal place to 2 decimal places or 3 decimal places. We're going to be using 3 decimal places here for each one of these. Right, so we're going to format them likewise. Now remember that the annual effective rate formula is given by 1 plus the nominal interest rate divided by its frequency to the power of the frequency minus 1. So that's what we're going to try to enter here. So equals, going to select open parenthesis now, 1 plus, we select the nominal interest rate divided by the frequency of conversion. Notice that the frequency of conversion here is 2 because it's semi-annual. Then we raise it to the power of 2 because that's the frequency of conversion minus 1. That will give us the rate as a decimal. We're now going to change this to a percentage and increase the decimal to 3 decimal places. Okay. Since we need to calculate the semi-annual, the effective rate, we will enter the same formula for each one of them. So we get this. We repeat the same thing for quarterly. So here we can copy the formula. You need to enter it all over again, and just change the value to 4 per quarter. Repeat the same process, change the percentage, increase the decimal places, drag down, repeat the same thing per monthly. So we enter 12 here, the 12 minus 1, percentage, increase the decimals, drag down. For daily, same thing. This one will be 365 to the power of 365. Percentage, increase the decimals, drag down. Now, for continuously, we have to be careful because the annual effective rate is given differently. So in this case, we will enter equals exp, and then we select the nominal rate, close parenthesis, minus 1. That simply means that the number is too big, so we can expand here, and we can decrease the decimal places, sorry, and then drop down. So make sure that you try to go over how to enter these formulae in Excel. It's very important to learn the fundamentals of manipulating Excel formula. Okay, so this concludes the video for the first lab assignment. Try to replicate the same thing, and like I said, ensure that you review how to enter the formula. It's very important and it's very applied. Thank you very much.